Good day, I am Christine Jarfrontila from BTLAHE2B, and we will talk about electronic components. Electronic components is any basic discrete device or physical entity in an electronic system used to affect electrons or their associated fields. So here are some examples are basic electronic components. Resistor. So what is a resistor? A resistor is a passive two-terminal electrical component that implements electrical resistance as a circuit element. In electronic circuits, resistors are used to reduce current flow, adjust signal levels to divided voltage, bias active elements, and terminate transition lines among other uses. And yung nasa baba ay a resistor symbol. So what does a resistor do? A resistor controls the flow of electrical current within a circuit. Resistors are made from material like copper or carbon, which make it difficult for the electrical charges to flow through a circuit. The most common type of resistor is a carbon resistor, which is a general purpose resistor, best suited for lower powered circuits. Some other common resistors types include the film resistor and the wire wound resistors. Resistors are essential to many electoral circuits, and they can be applied to a myriad of different applications. Resistors also protect components against voltage spikes. Components that are sensitive to high electrical current, like LED lights, will be damaged if there is not a resistor to control the flow of the electrical current. In addition, fuses circuit breakers can also be used to protect your electrical circuits against voltage spikes. Resistors ensure components receive the proper voltage by creating a voltage drop. They can protect a component from voltage spikes. Each component is an electrical circuit, like a light or a switch requires a specific voltage. If a component in your circuit requires less voltage than the rest of your circuit, a resistor will create a voltage drop to ensure the component does not receive too much voltage. The resistor will create a voltage drop by slowing down or resisting the electrons as they try to flow through the resistor. If a component receives too much voltage, it may be damaged or not function properly. Next is capacitor. Capacitor is a device that stores electrical energy in an electrical field. It is a passive electronic component with two terminals. The effect of capacitor is known as capacitance. Here a symbol. And the importance of capacitor. A capacitor is also known as a condenser. Is one of the basic components required for building electronic circuits. The design of a circuit is not complete or it will not function properly without basic components, like resistors, inductors, diodes, transistor, and etc. The main function of capacitors is to store electrostatic energy and electrical field, and give this energy to the circuit when necessary. They allow the AC to pass but block the flow of DC to avoid hazardous breakdown of the circuit. Though, capaci- through, though capacitors are tiny, they provide various benefits in electronic circuits. They store energy directly onto the plates, which make the charging and discharging process much faster. They are effective in filtering out unwanted frequencies. Capacitors can handle power loss efficiently and make power production more economical. They are less sensitive to temperature. Capacitors discharge current almost instantaneously. Capacitors are prepared for AC application. They are capable of handling high voltage application and they and are therefore suitable for high frequency use cases. Capacitors have a long life cycle of almost 10 to 15 years. Next is inductor. Inductor is also called a coil, choke, or reactor. It's a passive two-thermal electrical component that stores energy in a magnetic field when electric current flows through it. An inductor typically consists of an insulated wire wound into a coil. Inductors are used in tuning circuits. With the help of inductors, the tuning circuit can select the desired frequency. The capacitors type along with the inductor are used in various electronic devices such as radio tuning circuits, a television are ordered to modify the frequency and help to the select within multiple channels of frequency. These are used as sensors. The inductive proximity sensors are very reliable in operation and and is a contactless sensor. Inductance is the main principle behind it in which the magnetic field in the coil will oppose the flow of electric current. The proximity sensor's mechanism is used the traffic lights to detect traffic density. It also used to store energy in a device. Inductors can store energy for a small period of time because the energy which is being stored as a magnetic field will begin when the power supply is removed. Uses of inductor can be seen in computer circuits where power supply can be switched. Inductors are used for reducing current in AC circuit without any loss of electrical energy. When resistors are used, electrical energy is wasted in the form of heat. Next is transistor. A transistor is a semiconductor device used to amplify or switch electrical signals and power. The transistor is one of the basic building blocks of modern electronics. It is composed of semiconductor material, usually with at least three terminals for connection to an electronic circuit. A transistor consists of two p-n diodes connected back to back. It has three terminals, namely emitter, base, and collector. The basic idea behind the transistors is that it lets you control the flow of current through the one channel by varying the intensity of a much smaller current that's flowing through a second channel. Terminals of transistor as discussed in the previous section, a transistor is composed of three terminals, emitter, collector, and base. And we discuss the functionalities of each terminal detail. The base serves as a gate controller device for a larger electric supply. The collector is a larger electrical supply. And the outlet of that supply is the emitter. The current flowing through the gate from a collector can be regulated by sending varying levels of current from the base. In this manner, a very small amount of current can be used to control a large amount of current like amplifiers. Transistors work as switch or as an amplifier. Emitter is this segment is on the left side of the transistor. It is moderately sized and heavily doped. Base. This segment is at the center of the transistors. It is thin and lightly doped. Collector. This is segment is on the right side of the transistor. It is larger than the emitter and it is moderately doped. Base emitter junction is forward bias. There are flow of electrons host from the emitter to base and host. Electron from the base to emitter. However, since the concentration of emitter electron hosts are greater than the base host, electron this current is primarily made of electron hosts. This emitter's electrons host become minority carries the base. However, since the base is narrow, very little electron hole, recombination occurs in the base and these electrons are drawn toward the collector base junction. Collector base junction is reverse biased when this emitter's electrons reach the collector base junction. They are pulled across the junction into the collector by the electric field due to the depletion region ions. Lastly is relay. Relay is an electrically operated switch. It is consists of a set of input terminals for a single or multiple control signals and a set of operating contact terminals. The switch may have any number of contact and multiple contact forms such as make contacts, break contacts, or combination thereof. Relays are useful as switching mechanism for pinball machines, telephone stations, automobiles, and more. Relay construction. Almost all the relays work on same principle, but there are different types of relays are available in the market. I am going to give you a basic example of simple glass relay here. Relay working. As you have seen the above, uh, the main parts of relays are coil. The coil is the wire wound around the metal end. When the sufficient electrical power supply passes through this, it acts as a magnet. Moving armature. This is a moving part in the relay which opens and closes the contacts. An attached spring keeps the armature to its original position in a normal condition. Switch contacts. The relay is a switch. There must be contacts that are generally used to control another circuit. There are mainly two contacts, normally open and normally closed. Relay housing. The assembly of the armature with a magnetic coil is made with the help of spring. The spring is isolated from the armature by molded block and the switch contacts are usually spot welded on the terminal link. Relay operation. A relay is an electromagnetic switch. A user can turn it on or off, depends on the logic. Relay has an electromagnetic coil. There are mainly two conditions like when power flows through these coils, it generates magnet field that attracts the armature and make the contact. When there is no power to electromagnetic coil, the armature rests its position and breaks the contact. We can see the relay as the normal state on the left side and the contacts are often in this state. While on the right side, relay is the energized state and contacts are closed also. Which indicates the relay is energized. So that's all. Thank you.
So here is the continuation of the report of Miss Christine J. Fontillar. So the next basic electronics components is power. The unit of electrical power is the watt. Power is how much work is done over time. 1 watt of power is equals to the work done in 1 seconds by 1 volt moving 1 coulomb of charge. Since 1 coulomb a second is an ampere, therefore, power in watts is equals to volts times amperes. So here is the formula on how to get the power of how much work is done over time. So the first formula is power is equals to V or voltage or volts times I or current for intensity. So the second is power is equals to I squared times R or resistance. Last is power equals V squared divided R. Next is diode. A diode is a one-way valve or gate for electricity. Diode is a component with an asymmetrical transfer characteristic. A diode has low or ideally zero resistance in one direction, and high or ideally infinite resistance in the other direction. So diodes will help to protect your electrons. Next is diode circuit protection. In an electronic circuit, if the polarity is wrong, you can fry your components. As you can see in the picture, there is a anode which is the positive sides and cathodes which is the negative sides. A diodes that have a bar on the sides is the cathodes or the negative side. Next is light emitting diode or LED. A LED is a semiconductor light source. When electricity is passing through the diode, it emits light. Next, variable resistor or potentiometer. A potentiometer is a variable resistor. As you manually turn a dial, the resistance changes. Another is integrated circuit. An integrated circuit or IC is a set of transistors that is the controller or brain of an electronic circuit. An input is received and an output is sent out. Modern microprocessor ICs can have billions of transistors per square inch. Printed circuit board. Components are attached to a printed circuit board. The front side of the board will have printed components information such as resistor and resistance, diode type and polarity, etc. Holes go all the way through the board from one side to the other. Through hole soldering is needed to connect components to the board. Our last slide about the basic electronic components is back of circuit board. The back side of the board will have the lines indicating connections between components. The lines on the back are similar to wires. Thicker lines denote more current or electrons moving through. Components connect the lines.
Good day everyone, I am Alvincent Rodriguez and I am going to discuss resistor color codes. So ano ba yung resistor color codes? Yung resistor color codes ay yung mga stripes color na makikita natin sa isang resistor. Kung titingnan natin yung nasa picture, yung resistor code color is yung iba't ibang kulay na stripe sa isang resistor. So how to identify resistor color codes? So sa pamamagitan ng table na to, each color has corresponding digits, multiplier, and tolerance. Dito sa table nito, ma-identify kung ano yung value ng isang resistors. May iba't ibang type ng resistor. The first one is the 3-band resistors. Yung 3-band resistors ay ginagamit ng mga designers kung kinakailangan lang ng mababang value ng resistance. Next is the 4-band resistors. 4-band resistors are resistors na may 3 color bands located on the left side of the resistor and 1 on the right. Next is the 5-band resistor. Yung 5-band resistors naman ay may kabuo ang 5 color bands. Yung unang tatlo ay tinatawag na significant digits of resistance, and yung the last o yung pang-apat is the multiplier, and yung last is the tolerance ng resistor. Next is the 6-band resistors. Ito naman yung may 6 na stripes color na na codes. So the first three represent the resistance value. The fourth, fifth, and sixth are the multiplication factor, the tolerance, and the temperature coefficient respectively. So paano ba makakalculate yung value ng isang resistor? So, ang resistors ay may iba't ibang parts. So, yung unang stripe ay tinatawag na first band o first significant digit. Yung pangalawa ay second band or second significant digit. Yung pangatlo is the third band or third significant digit. Yung pang-apat is the fourth band o yung magsiserve as multiplier. And the last one is the fifth band, which is the tolerance. So, itong resistor nito is 5-band resistors. So, so ito, compute natin yung value ng resistor na ito. Ito ay 5-band resistor. So, ang solution is, the first one, the blue is equivalent to 6. Kung titingnan natin sa table kanina, yung blue is equals to 6. Yung gray is equals to 8. And the black one is 0. So, these are the significant digits. So, yung orange is 3, serves as the multiplier of the resistant. And the last one is the brown as the tolerance of the resistor. So, the resistor nominal value is 680 times 10 raised to 3 is 680,000 or 680k ohms, which has the tolerance of 1%. So, that's all. Thank you for listening.
Hello everyone. Before we proceed to the types of circuit boards, let us first define what it is. So, printed circuit boards or PCBs are the heart of all electronic products, but not all are created equal. There are many different types of printed circuit boards made from different materials and manufacturing specifications for a broad range of applications. Since the early 1900s, PCB have evolved considerably, and today, manufacturers like Advanced Circuits offer a broad range of circuit board fabrication capabilities, laminate materials, and certifications to meet the quality, precision, and performance demands for the latest technology requirements. Now, among the common types of printed circuit boards, there is the single layer. Single-layer printed circuit boards are among some of the simplest to design and manufacture. These boards have a single layer of conductive material such as copper on only one side of a non-conductive substrate. So this is what it looks like. So moving on to the next one, we have the double-layer PCB. So double-layer PCBs have one conductive layer on top of a non-conductive substrate and another conductive layer on the reverse side, making it top and bottom layers. The two conductive sides can be connected using plated holes in the substrate that connect to pads on both sides of the circuit board. These are all called vias. The next type is the multi-layer PCB. This term refers to a circuit board that has 3 or more conductive layers. The conductive layers are at the top and bottom, as well as at least one conductive layer sandwiched between non-conductive substrate. Advanced Circuits has the capability to fabricate up to 40-layer boards, but the most commonly used have lower layer counts such as 4, 6, or 8-layer boards. Another type is the high-density interconnect or HDI PCB. HDI PCBs take advantage of precision-based manufacturing technology to pack as much functionality into a small space. This is done by using many conductive layers, laser-drilled microvias, fine lines and tolerances, and advanced laminate materials. Also, HDI PCBs can accommodate the complex routing of high pin count chips and other high-tech miniatured components. So the last type is the high-frequency printed circuit boards. The main difference in manufacturing high-frequency printed circuit boards pertains to the design itself. These PCB are designed to facilitate signals over 1 GHz. Also, depending on the application, high-frequency printed circuit boards may require the use of advanced laminate materials and controlled impedance. Advanced circuits PCB manufacturing capabilities range from the simplest of designs to the most complex builds with the rigorous design requirements. So that concludes our group's report. I hope this serves as a valuable source of knowledge to you, and thank you for listening.